Hey everyone, in this video I'm going to go over the final part of this GUI for the NACA 4-digit airfoils. This one is all about saving the data out that we've already plotted. So in the previous video you saw that we plotted the airfoil using this plot airfoil function that I've minimized here. So the next part is to actually save the data. So if I just run this code right now and I just press plot airfoil, it plots the airfoil here, and what we get is are these four variables over here. So we have the x upper, y upper, and x lower, y lower. So the x upper and y upper define the upper part of the airfoil, starting from the leading edge here and then going to the trailing edge. The x lower, y lower defines the lower part of the airfoil from the leading edge to the trailing edge, like this. So you can see that if I open up x upper, you see it starts at 0 and goes to 1, and same with x lower, goes from 0 to 1. But then the y upper will be positive values, and y lower will be negative values, and they should be equal and opposite because this is a symmetric airfoil. So I'm loading these in here. I'm loading in the save file name. If we go up here, I'm just getting the save file name, just getting the HObject string from the edit text box, from this edit text box here. So you can type in whatever file name you want, and without the path. So in this case I just type naca.txt, and you can see here I've already saved it out. It'll save it out into the current folder that you're in. And then we also have the pop save type, so that is the here whether we want to save from the leading edge to the trailing edge or the trailing edge to the leading edge, and I'll show you why we want to do either one of those. And then the number of grid points we also want to evaluate in, and that's in this case 100, but I'm going to change that so we can compare to something online. So the first one we want to do is based off of which save type we're using, we want to flip the arrays for plotting. So because I showed you that the x lower or x upper and y upper, x upper was going from the leading edge to the trailing edge, then we might want to flip those. So let's just say that we're plotting the leading edge to the trailing edge. We know that that we're starting from the upper surface, so I'm going to start from here, and if I'm plotting leading edge to trailing edge, what I'm actually going to be saving out to my file is I'm starting on the upper, going around to the trailing edge, and then coming back around this way. So what we want to do is we want to flip the lower edge values. So I'm flipping, this is flip up down, and it's just flipping the column for these variables, so for the lower. But if I'm doing trailing edge to leading edge, then I'm starting here on the upper surface, and I'm going this way, writing out the file, writing out the file, writing out the file. So what I want to do is I actually want to flip the upper here. The lower is already in the right direction, so if I'm doing trailing edge to leading edge, I'm going to flip the upper data, and that's just what this is doing here. Then I want to open the file for writing, so the save file name from before is that naca.txt. I'm using fopen to open that file for writing, and then I'm going to print a header line that just says x and y as the headers, so you know which ones are the x points and which ones are the y points. And then I'm going to start writing the data. So I'm going to write the upper data first. I'm going to both sides, so both the upper and the lower both have the number of grid points. So this airfoil has 100 grid points on the top, 100 grid points on the bottom. So I'm going to loop through all of the grid points, and I'm going to write out this 2 floats with 6 decimal precision. And the first one I'm going to write out is the x upper, and then the next one is the y upper, and it goes through and then writes all these rows out. And then after it writes all the upper, I'm going to write the lower data, and this one you wonder why you can't just use this and write lower, and it's just a little thing that I do, and I'll show you actually in a second if I just run this. So I'm going to change this to a 0015 so we can compare to something online. I'm going to change this to 18 data points. So if I plot that, it looks kind of funky, but just stay with me. So I'm going to press save data. It saves it out here, and now I'm going to bring the notepad file in here. Whoops, daisy. Okay. And you can see that since we are going from, in our case, I said we are going from leading edge to trailing edge, so we're going to start at the leading edge. So we're starting at leading edge here, and we're going to go here, and then around this way. So we're starting at 0, 0, and then we're progressing along the top of the airfoil until we get to the trailing edge. And the trailing edge we're at 1 and a positive value, because remember I'm using an open trailing edge here, which means that the next value for the lower should be this at the same point, but just flipped around the x-axis. So you can see these two are that's the positive, this is the negative at the trailing edge. And then we're going along the lower surface back to the front, back to 0, 0. So that's what, let's see, that's what this one does here, is that we're going through all of the grid points because we do want to have this double here at 1 because there's an open trailing edge here. So then, in another sense, if I do the trailing edge to leading edge and I press save data and I go here and I update it, then you can see that we're going from on the top surface, we're starting on the top surface and we're going from here up here and then around back here. So we start at 1 and then the value at the upper surface, we're going decreasing values of x to the leading edge. So we're going to 0, 0 and then along the lower surface back to the trailing edge, and then we end up at that other point. And so the reason that I do this in here, that I start from 2 here as opposed to 1 here, is because in this case, this point at the leading edge for both of the upper and the lower, they're both 0, 0. So if I went from 1 to grid points, you would have 0, 0, you'd have 0, 0 here, and then you'd actually have another line of 0, 0. And that's just redundant in this case. So that's why I didn't, that's why I have these two different types here. And after writing it out, we just close the file. So let me just show you a comparison for to something online. So if you go to the, I'll post a link in the description to the Illinois Airfoil database, then you get something like this for a 0015 NACA with 18 points on the top and bottom. I just counted, you know, from here to here, it's 18 points. So that's why I have this 0015, 18 points. It looks like they're starting from the trailing edge. So I'm going to say trailing edge to leading edge, save the data, yes, update, and you can see that I have starting at 1 going to 0 like I said before, and we're at 0.001575. In this case they have 1 less precision here, they only have 5-digit precision, but they're starting at 1, going from 0.001575 essentially to 0 here, so there's no double repeated 0 there, which is why I have just 1 line here. And then in their file, they're on the lower surface now because you can see the negative y values, and they're going back to 1, to the opposite, flipped around the x-axis of the starting point. And so that comes, and similarly you can see it here. So if you're trying to compare to the online database, at least for this particular airfoil, I haven't looked at all of them. I mean, there's a ton of them, but they usually go from, it starts trailing edge and then goes to the other, so trailing edge upper to the leading edge and then to the trailing edge again. And so that's why I put these two different options in here depending on what you wanted to do. So that wraps up the NACA 4-digit airfoil GUI. I hope you enjoyed this series and let me know what you think. Thanks for watching.